Hi. Our topic is about inferring that the total momentum before and after collision is equal. Let's begin. Previously, we have discussed that moving objects have momentum which is affected by its mass and velocity. We also know that when objects collide, the momentum of each object involved in the collision may change. However, the momentum of the entire system is conserved. This is known as the law of conservation of momentum. In the absence of external forces, the total momentum of an isolated system is conserved. This means that the total momentum of the system before a collision is equal to the total momentum after a collision. Let's go back to the collision of a car and truck. By virtue of Newton's third law of motion, as the car exerts force to the truck also exerts an equal force to the car but in opposite direction. Hence, we can deduce that each vehicle experiences the same impulse. The impulse changes the momentum of each vehicle in equal amounts. If the momentum of the car increases, the momentum of the truck will decrease with the same amount of the car's change in momentum. The law of conservation of momentum holds for the three types of collision, namely, elastic, inelastic, and perfectly inelastic. This is because during collisions, only internal forces are acting and reacting within the system. There is no net external force. Let's have some example from each type of collision. The first type is elastic collision. In an elastic collision, if two blocks collide, they will separate after collision having their own velocities. If the blocks have equal mass and had a head-on elastic collision, their velocities will exchange. Moreover, in an elastic collision, the kinetic energy is conserved. Elastic collision is common in microscopic level but unlikely to happen in macroscopic level due to the presence of external forces. In an elastic collision, when two boxes collide, they will return to their initial position after collision. This is difficult to happen due to the presence of friction. Consider a collision between two marbles of the same size and mass on a frictionless surface. The red marble is initially at rest while the green marble is moving. Let us solve the initial and final momenta of the system. Let us first analyze the situation. The green marble will eventually come to a stop while the red marble will move away with velocity equal to the initial velocity of the green marble. From here, we can see that there is a transfer of momentum between the two marbles. Let us try to solve the initial and final momenta using the mean mass and velocity. We can see that the initial and final momenta are the same. This means that momentum is conserved. If we will solve the kinetic energy before and after collision, we can see that the kinetic energy is conserved. On one hand, after a collision, the two bodies will separate after both having their own kinetic energy. The total kinetic energy of the system is conserved. Let us analyze the situation. Before the collision, both marbles are moving to the right, but after the collision, the green marble will continue moving to the right while the red marble will move to the left. Moreover, after the collision, the velocity of the green marble increased while that of the red marble decreased. Let us try to solve the initial and final momenta using the given mass and velocity. Based on our calculations, the momentum is conserved. On the other hand, if we will solve the kinetic energy before and after collision, we can see that the kinetic energy is not conserved. In this situation, if these two blocks had a perfectly inelastic collision, they will stick together after collision moving with a common velocity. In this type of collision, kinetic energy is not conserved. Let's use this example again. If these two marbles had a perfectly inelastic collision, in a perfectly inelastic collision, the colliding objects stick together after the collision. Unlike a regular inelastic collision, the final velocity of the combined object in a perfectly inelastic collision is usually not the average of the initial velocities of the two colliding objects. Let's try to compute the initial and final momenta of the system given the following velocities. Let us analyze the situation. In a perfect inelastic collision, the marbles will stick together after collision. Let's try to see the initial and final momenta using the given mass and velocity. Based on our calculations, the momentum is conserved. On the other hand, if we will solve the kinetic energy before and after collision, we can see that the kinetic energy is not conserved. In summary, we have learned that in the absence of external forces, momentum is equal before and after any type of collision. This is a principle in physics called the conservation of momentum. It states that in an isolated system, the total momentum of the system remains constant over time. In other words, the total momentum before a collision is equal to the total momentum after a collision. This principle applies to all types of collisions: elastic, inelastic, and perfectly inelastic collision. Let us test your knowledge. Which of the following statements is true? A. The momentum of a system is lower after collision. B. The momentum of a system is higher after collision. C. The momentum of a system is equal before and after collision. D. The momentum of a system is always zero after collision. The correct answer is C. The momentum of a system is equal before and after collision. Number 2. A 2 kg box moving at a velocity of 2 meters per second collided with a 500 grams box moving at 1 meter per second in the same direction. After collision, the boxes moved at the same velocity of 1.8 meters per second. Find the initial and final momenta of the system. A. Initial momentum 4 kilograms meter per seconds, final momentum 6 kilograms meter per seconds. B. Initial momentum 4.5 kilograms meter per seconds, final momentum 4.5 kilograms meter per seconds. C. Initial momentum 1 kilogram meter per seconds, final momentum 1 kilogram meter per seconds. D. Initial momentum 6 kilograms meter per seconds, final momentum 4 kilograms meter per seconds. The correct answer is B. Initial momentum 4.5 kilograms meter per seconds, final momentum 4.5 kilograms meter per seconds. Number 3. Ball A has a mass of 500 grams and is initially at rest. Ball B has a mass of 250 grams and is moving at 3 meters per second. What will be the velocity of ball A if the velocity of ball B remained the same after collision? A. 0 meters per second, B. 1 meter per second, C. 2 meters per second, D. 3 meters per second. The correct answer is A. 0 meters per second. Number 4. Consider a collision between two marbles. Before collision, the momentum of marble A is 0.1 kilograms meter per seconds, while marble B has a momentum of 0.2 kilograms meter per seconds. After the collision, marble A stops. What is the momentum of marble B? A. 0 kilograms meter per seconds, B. 0.1 kilograms meter per seconds, C. 0.2 kilograms meter per seconds, D. 0.3 kilograms meter per seconds. The correct answer is D. 0.3 kilograms meter per seconds. Number 5. A bullet moving at 100 meters per second was fired and hit a 30 grams block of wood. The block of wood together with the bullet moved at 5 meters per second after collision. What is the mass of the bullet if the block of wood is initially at rest? A. 1.28 grams, B. 1.38 grams, C. 1.48 grams, D. 1.58 grams. The correct answer is D. 1.58 grams. How many correct answers did you get? If you got all the correct answers, you are doing great. If not, you may review this video again. Thank you, and see you on the next video.
If you enjoyed this video, don't forget to give it a thumbs up and share it with your friends. And if you haven't already, make sure you hit that subscribe button and turn on the notification bell, so you never miss a new video. Also, feel free to leave a comment down below with any feedback or suggestions for future videos. I appreciate your support, and I'll see you in the next one.